The history of exploration for life on Mars began as early as the mid-1900s because astronomers realized that Mars existed in the habitable zone, meaning that life could exist on this planet. In addition, Mars was often the setting for science fiction novels in the 20th century that depicted Mars as a planet full of alien civilizations. However, this obviously isn't proof that Mars actually contains life, so NASA sends out 2 operations in the 70s, Viking 1 and 2, and these were the first to begin exploring for life on Mars. However, these operations didn't find any signs of life, although they did find evidence of previous water on Mars, meaning that life could have existed at some point in the past. There were other famous examples of attempts to explain possible life on Mars, like in 1996 when scientists claimed a meteorite that had landed in Antarctica from Mars contained evidence of fossilized bacterial life. However, this was later disproved by scientists. This means that so far, we haven't found any first-hand evidence of life on Mars with our past missions, but we have found evidence that water has existed on Mars in the past, meaning that life as well could have existed at some point.
Curiosity, a rover built by NASA to further explore the surface of Mars, unveiled mud cracks in the transitional zone between clay and sulfate layers, making a shift from wet to dry conditions in the planet's history. These hexagonal cracks, formed by the drying and shrinking of mud, persisted over time, suggesting enduring wet-dry cycles. Chem-cam analysis confirmed the presence of sulfate crusts along the cracks, preserving this geological record for billions of years and indicating a connection with Mars's sulfate-rich region. This discovery provides tangible evidence of Earth-like wet-dry cycles on ancient Mars, with potential implications for molecular evolution and the origin of life. The conditions that support life are complex, requiring a delicate balance. The findings highlight the importance of continued exploration, as the Pontour's mud cracks offer a unique opportunity to discover remnants of the environment that may have given rise to life on Mars. Scientists emphasize the significance of this revelation in unraveling the mysteries of Mars and its potential role in the broader context of life's origins.
Eleven, 10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
One of the biggest questions still asked today about the exploration of Mars is, why haven't we sent humans to explore it? There are a lot of factors that prohibit us from traveling to a planet like Mars. Its atmosphere is 95% carbon dioxide, completely unbreathable to humans. The different gravity having negative long-term impacts on astronauts used to Earth's gravity, acquiring enough funds for the resources needed to overcome these obstacles, and many more. Scientists from all over the world have been working for decades to try and come up with solutions to these limiting factors, most involving careful research with rovers like NASA's Curiosity or Perseverance. With the data collected from these machines, the scientists back on Earth can make simulations to test out tools to protect spacefaring astronauts. As more data is retrieved from these rover missions, scientists can make further conclusions about what exactly a human would need to survive on Mars.